Today we're going to be talking about the final section that will be on your quiz on Monday, 7.3 compound events. Can anyone tell me what this word compound means?
Complicated.
Doubled? Okay, it means more than one, all right? So today we're going to be talking about more than one events happening. There is a vocab word that I'd like you to write down with your red pen, sample space. So the sample space is the set of all possible outcomes of one or more events. Remind me again, what does this word outcomes mean?
Like
The possibilities of it happening.
Okay, possibilities of what comes out of the experiment, okay? So the sample space, the result, that's good. The sample space is basically creating us a space to be able to show what those outcomes are going to be. So the first scenario that we have today is find the sample space using a tree diagram. This is what it says. You randomly choose a bread and type of sandwich. Find the sample space. How many different sandwiches are possible? How many of you can think of a favorite sandwich shop where you might go to get a sandwich? Where could you go? Subway. Okay, where else could you go? Firehouse Subs. Who's got another one? Larry's Giant Subs. Anyone else have another one? Say it out. What do you got?
My grandma's house.
Your grandma's house? Okay, does she have lots of options for you? All right, very cool. So at this specific sandwich shop, there are two kinds of bread. What are the two kinds of bread they have at their shop?
Wheat and sourdough.
Wheat and sourdough. So all the way on the left side, I want you to write down bread. Give yourself a little bit of space, so skip a little bit and write down the word wheat. That's the first kind of bread they tell us that they have available. And the second kind, once again, give yourself some space, is sourdough bread. They have two kinds of bread. Now there's 4 types of meat. So if you would over here, give yourself a little space once again, and I want you to write out the 4 types of sandwiches you could get. You could get ham, turkey, steak, or chicken. Then looking at that, if you would just draw lines, you could have ham on wheat, turkey on wheat, steak on wheat, and chicken on wheat. Now there's another kind of bread. What was the other bread we talked about? Sourdough. On that, how many different types of meat could you have on sourdough bread? All of them, which is? All 4 of them. Ham, turkey, steak, and chicken. So write that there next to the sourdough. And then go ahead and draw lines to the options that you could have. So this is what we call a tree diagram. It shows you the different types that you can have. So looking over here, I would like us to write the word outcome. The first outcome you could have is wheat bread and what meat? Ham. Okay, I'm just going to put a W for that. So we could do wheat with ham. What's the next thing I could do? Wheat with turkey. And then I could have wheat with steak, and finally wheat with chicken. And wheat with chicken. All right, so these are the different outcomes that we could come up with. Wheat is not the only kind of bread. What's the other one? Sourdough. So I'm just going to write SD for sourdough. First, I could have sourdough with ham, sourdough with turkey, and then you'll finish it out with the steak and with the chicken. So let's go back to our original problem where it says, how many different sandwiches are possible? What's the answer, guys?
Like 8.
There are 8 sandwich, we'll say, outcomes. Okay? You could see up here, there's 4 different options with the wheat and 4 different options with the sourdough. So 4 plus 4 equals 8. There are a total of 8 sandwich outcomes. All right, for number 2, I'm going to teach you kind of an easier way of doing what we just did, or maybe just a faster way. It says to use the fundamental counting principle to find the total number of possible outcomes. So with your red pen, I want you to fill in those 3 blanks there, fundamental counting principle. What it tells you to do with the fundamental counting principle is to multiply the possible outcomes from each category together to find the total number of possible outcomes. Now, if you remember, we're talking about compound events, so it's more than one event happening. Our problem says to find the total number of possible outcomes of rolling a number cube and of flipping a coin. I want you to take your pencil and go ahead and underline rolling a number cube. That'll be the first thing we focus on and talk about today. And the second thing is flipping a what? A coin. So the first event, guys, how many different numbers are on a number cube?
Like
6. All right, so let's write a 6 down. How many different numbers are over here when I flip a coin? 2. The fundamental counting principles tell me that I can simply multiply those two together and it will give me my answer. What's 6 times 2? 12. All right, now units attached, 12 possible outcomes. So going back to what we just did with the sandwiches, remind me, how many types of bread did we have? 2. How many kinds of meat did we have?
4.
Multiply that together, what do you get? 8. Which way was faster, the tree diagram or the fundamental counting principle? All right, so for the remainder of class today, we are going to focus on the fundamental counting principle instead of the tree diagram because it is much faster and I would say quite a bit easier. For problem number 3, it says to find the total number of possible outcomes. I want you to look at the picture that I have up here on the screen, and it asks us how many different outfits we could make from the wardrobe closet. Looking at the top, how many pairs of pants do we have folded up there? There are 4 pairs of pants. Everyone write down a 4. Next, we're going to focus on the shirts that they could wear with that. Count the hangers if you want, or the color of shirts. How many shirts are there? 7. And the fundamental counting principle says I'm going to do what to those numbers? Multiply them. Now, there's still another option of something that they can wear with their pants and their shirt. It's a pair of... How many pairs of shoes are down here? There's 6 shoes, but how many pairs? There are 3 pairs. Okay, so we'll multiply it times 3. Now, I don't want you to pull out your calculators. I want us to do this. Remember, the commutative property tells me I can move these numbers around and multiply them in any order. So let's just do the tinier numbers. What's 4 times 3? 12. What's 12 times 7? What is it? 84. Okay, once again, units attached. So we've got... Okay, you could say 84 possible outcomes. If you look here, it says how many different outfits. So you could also write in different outfits. Either one of those would be fine. Possible outcomes or different outfits. Now, problem B is very similar to what we just did. I want you to try to do problem B on your own. Noah, how did you do problem B?
It says 4 t-shirts, 4 t-shirts, 5 pairs of jeans, 5 pairs of shoes, 4 times 5 times 5 equals 100.
Okay, 4 times 5 times 5 equals 100 what? Okay, possible outfits, possible outcomes, different outcomes. You guys can choose what you would prefer. Just make sure you have some kind of units attached. But that is correct because when you multiply those together, you do get 100 different options or 100 different outfits. For this next one, go ahead and turn the page. It says find the probability of the compound event when rolling a number cube and flipping a coin. I want you to take your red pen and draw a red fluffy cloud around the words compound event. Remind me again, what does compound event? What's a compound mean? More than one event. Okay, so we're just drawing a cloud around that to help us to remember this is going to be more than one event. So the first thing it's asking us in problem A, what is the probability of rolling a number greater than 4? Underline that for me with your red pen. And the second one is also finding if you could flip tails when flipping that coin. So it tells us here that we're doing some kind of probability. We are not actually doing the experiment, so it's not experimental probability. What kind of probability is this? Theoretical. Okay, so in theory, what would probably happen? What was the formula for theoretical probability?
1 over the thing.
Favorable Divided by the total. With your red pen, I want you to write that down because this is important. On your quiz coming up on Monday, you're going to need to know this definition or this formula. Favorable divided by the total. So once again, this is a compound event. Let's look at the first thing we underlined. Rolling a number greater than 4. Thinking of a number cube like we've got in the bottom left of that picture. How many numbers are on there that are greater than 4? 2 of them are. What are those numbers?
5 and 6.
A 5 and 6, okay? So favorable would be 2. How many total numbers are on the cube? 6. So 2 divided by 6. Is that the only event we're calculating? No. What's the other one we underlined? Flipping tails. How many tails are on a coin? 1 out of how many? Out of 2 sides. So 1 out of 2 sides. Remember our fundamental counting principle. What should I do to those 2 events? Multiply them together. Okay, we're just going to multiply across the numerator. Guys, what's 2 times 1?
2.
And what's 6 times 2? 12. Can 2/12 be reduced at all? Yeah, what would you reduce it to? 1/6. Okay, so there is a 1 out of 6 chance of me rolling a number greater than 4 and flipping tails if I did both of them. Now, I would like us to change this to a decimal and then to a percent. What would 1/6 be as a decimal?
0.01.
16 and 18.
Okay, that 6 is repeating, okay? Now, how do I change that to a percent? Move that decimal 2 places to the right, leaving me with 16.666. The 6's just keep repeating, okay? Now, whenever we have something like this, I'd rather it be rounded to the nearest whole number. What would that be rounded to the nearest whole number? 17%, okay? That whole number is going to look to the number next to it, see if it's 5 or bigger. If it is, then it bumps up to 17%. Now let's talk back about, I think we did it in 7.1, the likelihood of that happening. What word goes with that? The likelihood. Unlikely, okay? It is unlikely that you are going to roll a number greater than 4 and flip tails. Let's try another example, very similar to this. What is the probability of rolling at most 4 and flipping heads? Okay, so what's the first thing we're looking for? At most 4. What's the second thing we're looking for?
Flipping heads.
Flipping heads. Underline those 2 compound events. And remind me once again, what's the formula that I'm going to be using? Favorable over total. All right, Huang. Rolling at most 4. How many numbers are on that cube that are at the most the number 4?
1.
Not just 1.
There's 4.
There's 4. What are the 4 numbers that are the most they could be is 4?
1, 2, 3, 4.
1, 2, 3, and 4. Okay, so favorably, there are 4 options on there that the most they are is 4. It could not be a 5 or 6 because the most it could be is a 4. A 5 or a 6 would be bigger than that. Okay, Einar, how many total numbers are on my cube? There are 6. So I have a 4 out of 6 chance of getting that. Let's look at the flipping heads. Trenton, how many heads are on a coin? 1. Jalen, how many total sides are on a coin? How many sides are on a coin? There are 2. So I have a 1 out of 2 chance, a 50-50 chance of flipping heads. What should I do with those 2 fractions? Multiply them together. The fundamental counting principle tells me I can multiply them together to figure out my possible outcomes. When I multiply those out, 4 times 1 is? 6 times 2 is? Can that be reduced?
Yes.
To what? 1/3. Okay, 1/3. Now remember, if you wanted to, you could always go back here and cross this out, 1 and 2, cross reduce it first if you wanted to, okay? And then still you would reduce it down to 1/3. Hope, what is 1/3 as a decimal? 0.3 repeating, okay? Now I want to take that and turn it into a percentage. Angeline, how would I do that? Very good. We're going to move that decimal 2 places to the right, okay? And that would give me 33.33333 repeating percent. Once again, I would like this to be rounded to the nearest whole number. Hayden, what would that be rounded to the nearest whole number?
33%.
You are correct. Okay, that whole number looks to the number next to it, realizes it's smaller, so it stays at the 33%. What's the likelihood of this happening, class? It is also unlikely. Remember, anything between 1 and 49% is going to be unlikely. For number 5, it's going to be the same kind of idea, but this time instead of focusing on it being a number cube or a dice, we are going to look at this little spinner that we have both on our paper and up here on my screen. So you spin the spinner and you're going to flip a coin. Find the probability of the compound event and round to the nearest whole percent. What's the first thing that we're looking for right now? Spinning an odd number, okay? So let's underline that. What's the second thing we're looking for? Flipping tails. Let's go down here and focus on this. How many odd numbers do you guys see? 4. What are they? 3, 5, 7, and what was the other one? 1, okay? So once again, for this one, we know that we are looking for favorable over total. And you guys just told me that there are 4 favorable options. There's 4 options of getting an odd number out of how many total numbers were on that spinner?
8.
8. Reese, what is the probability of flipping tails? How many tails are on the coin?
Oh, we don't know the point. 2.
How many tails are on the coin?
Oh,
1 out of how many?
2.
So I've got a 1 out of 2 chance. Let's go ahead and multiply that together. Once again, as I said before, you can cross reduce if you'd like. When you get that, you get 2 eighths. Can 2 eighths reduce?
To 1/4.
To 1/4. What percent is 1/4?
0.25.
Okay, 0.25 you want a decimal, but if I want that as a percent,
25%.
25%.
Unlikely.
Also unlikely that this would probably happen. Let me have you guys try to do problem B on your own. All right, how many of you would say that you found somebody else who had the same answer as you? Okay, so we have a lot of different answers. Let's focus back on this. What's the formula we're using? Favorable over total. So the first thing we're looking for is the probability of spinning a number less than 4. This is where I think people got confused. Which numbers over here are less than 4? 3, 2, and 1. Okay, some people were thinking 4 was. Is 4 less than 4? No, it's equal to. Okay, so we only have 3 favorable outcomes out of how many total are on my spinner? 8. Second thing we're looking at, flipping heads. What is the probability I could flip heads? 1 out of 2. Okay, multiply those together. What do you get?
3 over 16.
3 over 16. What would that be as a decimal?
0.1875.
Okay, once again, we want to make sure we're turning this into a percentage. When you get that, you get 18.75%. But I asked you to round to the nearest whole number. What do you get? 19% is correct. How many of you got 19%? Okay, very good. If you did not get 19%, who has a question for me? Anyone? This next part is not actually in your notes, but I do want you to try to just kind of squeeze it at the bottom. If you would, write the word review. And then I want you to write out A and B as your original problem. You're going to find homework problems just like this tonight. So I want to go through a couple of these before we get started on our homework. For the first review problem, it says use the bar graph to find the experimental probability. What's the formula for experimental probability?
It's trials over successes.
Flip that.
Successes over trials.
Very good. Okay, so write this down. This is something that you're going to want to know for tonight's homework. Successes divided by trials. So if I look down here, this is, you don't need to copy down this chart, but the first 2 problems of your homework today are going to be the same exact chart. So I wanted to just get you kind of familiar with this. There are 6 different numbers they could roll. Does anyone see how many times they rolled the number 1? 13. How about the number 3?
15.
15. What about the number 6? 20. Okay, so above here on each of them, it tells us how many times they rolled that. What are we looking for in problem A?
5.
Rolling a 5. Guys, how many times did they roll a 5?
19.
Very good. Right up there, 19 times they rolled a 5. So successfully, they got it 19 times. Out of, how many times did they roll this all completely? How could I figure that out? You are correct. I'm going to add up how many times they got a 1, 2, 3, 4, 5, and 6. I want you guys to stick that in your calculator, add all those up together. Isaac, what'd you get when you added all those numbers together?
I'm still adding. 100.
100. They had 100 total trials. Now, I would like this to be a percent. Guys, 19 out of 100, what percentage is that? This should be an easy one.
I was 19.
Okay, that would be 19% of the time they rolled a 5. Okay, I want you to go to the next one, the final problem for today, B, rolling a 1 or 2. We know that we are doing, once again, successes divided by the times you did it or the trials. Try to find that on your own and stand once you have it. All right, so as we walked around, I had a few people who I heard say, I just don't get it. What are we looking for? What successes am I hoping to find? Rolling a 1 or a 2. Guys, how many 1s were there?
13.
There were 13 of them. How many 2s were there?
16.
I would be successful if I got a 1 or a 2. So how many total is 1 and 2 put together? 29. How'd you get that?
Because I added 13.
You just add those two together. So when it says this or this, it means I would be happy with either of those. Either of those would be considered a success. So we would have 29 out of, how many trials were there total? Still out of 100. We already counted those together. And what percentage is 29 over 100? It is 29%. Okay, if you did not get that, please erase it and fix it. Remember, when it says this or that, you just add those two successes together. All right, so tonight we do have 8 problems for homework. If you would, please pull out your phones to work on Big Ideas 7.3.